So this lesson number 8 for Math 20-1, lesson number 5 for 20-2, looks at problem-solving questions in which you're not actually told what to use to solve it. So when we were looking at the previous lessons, the lesson on cosine law meant that you were using the cosine law. The lesson on the sine law meant that you were probably using the sine law. In this case here, you're given a problem and you're asked to solve for a missing measurement and you're not told how to do it. So the two things to remember, if you have a right triangle, you revert back to SOHCAHTOA. That's what right triangles use, is SOHCAHTOA. If you are not given a right triangle, if it's called an oblique, so it could be an acute, obtuse, it's a non-right triangle. To figure out between using the cosine law and the sine law, start with the cosine law. The cosine law can be used in two conditions: when you have all three sides, or when you have two sides in the contained angle. So when I can draw the letter C. So if I can draw the letter C around my triangle components, the parts that I'm given, I can use the cosine law. If I have all three sides, I can use the cosine law. If you can't use the cosine law, then you're using the sine law. That's the default. So what we're going to look at first is some review about circles. It goes back to grade 9. Yay! Circle geometry. The perpendicular line drawn from the center of a circle to a chord. So perpendicular means it's going to hit this chord at a 90-degree angle. What does it do to the chord? Splits it in half. And we have a special word for that? It bisects the chord. So that was one of those ones that we did where if a line bisects the chord, it's going to go through the center of the circle. If a line goes through the center of a circle and it bisects the chord, it has to be at a 90 degree. This is useful because this right here, if I drop a line, now I have a right triangle. So that's where that can be used, is the fact that if I draw this line bisecting this chord, I now have a 90-degree angle. I would be able to then find some other calculations. This one is for this diagram, B and C. The measure of the central angle is equal to what of the measure of the inscribed angle subtended by the same arc? So first of all, subtended by the same arc means from A to C. That's my arc. So I can close all of my angles up by starting at A, going to a point, and then going to C. The central angle goes to the center of the circle. That becomes my central angle subtended by the arc AC. This is my inscribed angle. Goes from A to S to C. Who remembers what the relationship is between these two angle measurements? What is it, Bobby Ann?
It's like the y angle half of it.
Yeah. So the measure of the central angle would be twice the measurement of the inscribed angle. So if the inscribed angle was 30 degrees, the central angle would be 60 degrees. The other theory, or the other property, is inscribed angles that are subtended by the same arc. So in other words, ASC and ARC, what can you tell me about angle Y and angle Z? They're the same. So they're called inscribed angles subtended by the same arc. They are equal. And then the last one, a tangent to a circle. So a tangent is a line that touches the circle in one point. If I draw a line from that point to the center of the circle, which is the radius, what do I know about these two lines? How do they intersect? What kind of an angle? They make a 90-degree angle. And we say that that means it's perpendicular. So a tangent to a circle is perpendicular to the radius of the circle at the point of tangency. So we're going to use that on the next page to solve the first question. In the following diagram, O is the center of the circle and it has a radius of 3.25 centimeters. The distance from Q to R is 2.5. The distance from R to S is 4.7. Calculate the length of PQ. So with some of these, you may find it easier to pull the triangle out of the circle and sketch it so that it's a bit easier to see. If I look at PQR, there's R, Q, and P. Q to R, I was given. It's 2.5 centimeters. Can I figure out the distance from P to R? Given that the radius is 3.25 centimeters? Be double the radius, so what's double 3 1/4? 6 1/2. One last theory or property that wasn't on the previous page. If I have an angle inscribed in a semicircle, what do I know about this angle here? If I inscribe an angle in a semicircle, I will get a 90-degree angle. So angle Q is 90 degrees because it's angles in a semicircle. So how do I find PQ? What kind of triangle do I have? So if I know two sides of a right triangle, how do I find the third? Pythagoras theorem. So in Pythagoras theorem, which is my c squared? The hypotenuse. Which one's the hypotenuse? PR. So PR squared would be equal to PQ squared plus QR squared. So PR I know. PQ is what I'm trying to find out. And QR I know. So I'm going to give you a moment and I want you to finish up the question and find what the length of PQ is. So PQ squared would be equal to 6.5 squared minus 2.5 squared, which equaled 36. To get rid of the squaring, I have to square root. And PQ equals 6 centimeters. Actually, it would just be 6. So in part B, you're asked to calculate the measurement of QPR. That's this angle right here. So I still have my 90-degree angle. This is still 2.5 and this is still 6.5. How do I find angles in a right triangle? What do I use? Go back to the previous page at the top. If I have a right triangle, what do I use to solve? SOHCAHTOA. So in terms of this angle, what do I call this side? What do I call this side? So which trig function has opposite and hypotenuse? Sine. So the sine of angle P will equal 2.5 over 6.5. So then to find angle P, what would I have to do? What do I use on my calculator to find the angle? The inverse. So it would be inverse sine 2.5 divided by 6.5. And what do I get? So inverse sine that, and what do you get? I think something went wrong there. Just give me a second. So now that you're in degree mode, what would that be?
22.649.
So to the nearest whole number? 23 degrees. Okay? So now if I look at the next one, the measurement of SQR. So if I take that circle, and if I was to scribe out Q, R, S, I know that the length of Q to R is 2.5 because we figured that out already. And do I know anything else? Oh, right, because that was given to me. What can you tell me about angle P and angle Q or angle S? Why are they equal? They both are inscribed from that same arc. So they both come from arc QR. So that means that angle S would have to be 23 degrees. So this is not a right triangle. I can't prove that it's a right triangle. I can't look at this and say, well, angle R kind of, well, no, it doesn't. Even the way that it's drawn, it does not look like a 90-degree angle. So the only way that you can say it's 90 degrees is if you have some level of proof. Q we could say was 90 degrees because of the property. It's inscribed in a semicircle. So with this one, because we no longer have a 90-degree triangle, we're either looking at the cosine law or the sine law. So we start with the cosine law. Cosine law can be used if I have 3 sides. Do I have 3 sides? No. It can also be used if I have a side, angle, side. So it's 2 sides in the contained angle. There's 2 sides. Where's the contained angle? Angle R, which I don't have. So I can't use the cosine law, which means by default I'm using the sine law. So I want to find out angle Q. So that would be sine Q is to side Q, which is 4.7, as sine 23 degrees is to 2.5. So to get Q or sine Q by itself, I'll multiply both sides by 4.7. And then I'll have to do the sine inverse of that answer. And what do you get for angle Q? Thank you. Okay, so let's move along into some problem-solving questions. Before we get into problem-solving scenarios, we need to talk about bearings. When it comes to describing direction, there's 2 ways that you can describe direction, and I'm going to go through the first one, bearings first. A bearing of 1 point from a second point is a way of giving a direction. The diagram shows 2 points A and B and the north-south line through A. The bearing of B to A is a measure of angle NAB, and it's 125 degrees. Bearings are measured from north in a clockwise direction. So it's backwards from what we were doing before with our rotation and our reference angles. A bearing means that I'm looking at north and I'm going clockwise. So if I